What's up, guys? It's Final Exam Guy, and I'm back with a brand new video for you guys. It's 10 solved problems in derivatives. So we're not going to do the chain rule here. It's just going to be strictly basic derivatives and using the limit definition of the derivative as well. In the next video, we'll be doing 10 solved problems in chain rules. Don't forget to check out my final exam full walkthroughs. I'll walk you through a full exam and we'll solve it together. Calculus 1 and Calculus 2 as well. Calculus 3 will be coming out eventually. So let's get started here, guys. Sorry. Just don't forget to subscribe to my channel so you never miss out on any of my future videos. And you can learn for days with me. So let's have fun. Number 1, using the delta definition, find a derivative f prime of x of the function f of x is equal to 2x minus 7. So the limit definition of the derivative is what we're going to be using here. That's what they're saying. So they're saying that f prime of x is equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. So what you do here is that in this first term here, wherever you have an x, you add a delta x to it in the function, and then you subtract from it the regular function, and you divide by delta x. So let's go ahead and do that here. So I'm gonna write the limit x approaches 0 of 2, but instead of writing x, I gotta write x plus delta x minus 7. Oops. Yeah, it's minus 7, like that, and then we have subtracting the original function. Like that, and then we divide by delta x. So if I try to plug in 0 here, we're going to get negative 7 minus negative 7 over delta x, which doesn't really give us an answer. Let's try to simplify this further so we get the limit as x approaches 0. Delta x, by the way, it's important to not get confused. Some textbooks, some teachers use h instead of delta x, so we don't get confused. So let's multiply all that in, so we get 2x plus 2 delta x minus 7. Let's drop the brackets on the next term. Minus 2x plus 7 over delta x. So simplifying further, we get cancels. We get the limit x approaches 0 of 2 delta x over delta x. Cancels. We just get 2. That often happens in limit definition problems. Stuff gets canceled out, so you're left with something really simple. Alright, so let's move on to the next one. Alright, let's do another one here. I use the delta definition, find the derivative f prime of x of the function f of x is equal to 2x squared minus 3x plus 5. Let's use h here, just because some professors use h, so let's mix it up and try doing it with h here. So our limit definition function will be the limit as h approaches 0 of f of x plus h minus f of x all over h. It is delta, but we can always drop that and just work with what we have here. So if I'm plugging, where every time I have an x, I plug in h, I'll have 2x plus h squared minus 3x plus h plus 5, all that in brackets, minus our original function, 2x squared minus 3x plus 5, all over delta h itself. Okay, so now if I go ahead and multiply all this out, this here, x plus h squared, we'll have to FOIL that, so let's go ahead and just FOIL it on this side over here, so we get x squared plus 2xh plus h squared. And then if I multiply this 2 in, so further simplifying, we get 2x squared plus 4xh plus 2h squared and minus 3x minus 3h plus 5. Distribute this negative, minus 2x squared plus 3x minus 5.
So now all over h. Let's see what cancels out here. So this cancels out with this cancels out with this 2x squared, this 2x squared, and we're left with the following. Oh, that's from another problem. Let me just take that out in black, hopefully. Alright. Big eraser. Alright, so just going over really quick. We get the limit as h equals to 0 of 4xh plus 2h squared minus 3h all over h. I can do term-wise division here, so I'll get the limit h equals to 0 of 4xh over h plus 2h squared over h minus 3h over h. So we get the limit as h equals to 0 of 4x plus 2h minus 3. And if we plug in 0 here, we get, for h, we get 4x minus 3. And that is our answer. And it's okay if your answer is in terms of x. It doesn't have to be an actual number. It could be in terms of x, and you can leave it like that. Just a little mistake I made here. There should be no equal sign. I mean, it's just this should be gone. It should not be there. And this answer here is the derivative. So f prime of x is equal to 4x minus 3. Alright, let's move on to the next question.
Alright guys, let's do one more limit using the limit rule, just to solidify our understanding of this one. So we have the function is equal to x cubed. So we have the limit definition of f prime of x is equal to limit. We'll use h as h equals to 0 of f of x plus h. So everywhere there's a h. At x we added h to it. So x plus h cubed and minus the original function all over h. So the only annoying part is this cubed cube over here. So when we read it here, the limit is h equals to 0. So I just went ahead and fold this all out, multiplied it all out, and I got this. And then we subtracted by x cubed all over h. Go under, so let this go down a bit, and let's distribute everything, add and subtract. So x cubed minus x cubed, these will cancel out, and the rest doesn't cancel out. So we got 3x squared h plus 3x h cubed squared plus h cubed all over h. Everything has a common factor of h, so we will get pull out a h, 3x squared plus 3xh plus h squared all over h. So we can cancel out, this is the limit of h equals 0, we can cancel out this. And if we plug in 0 for our h here, this term goes to 0, and this term goes to 0, so we're just left with 3x squared. So that's it for limit definition, and now we'll move on to actual derivatives, the easy way, well, less long. Alright guys, so number 4 says to write the derivative of the function 7x to the power 5 minus 2x to the power 4 plus 6x squared plus 3x plus 4. So just a quick rule here. So if we have a term a to the power of b, its derivative f prime would be you bring down the exponent to the front and subtract 1 from the exponent and put that back in the exponent. So b times a to the power of b minus 1. So let's apply that to here because every term kind of pretty much looks like that. So f prime of x, so 7x5, we'll bring the 5 to the front, so we'll multiply by 7, that's 35. We'll leave the x there, and then subtract 1 from what used to be the exponent. So 5 minus 1 is 4. Same thing with the next one. So minus, we'll bring the 4 to the front, so 4 times 3 is 12, x, and then we subtract 1 from the exponent and put a 3 there, and then the same thing. So 2 times 6 is 12. Subtract 1 from the exponent, we're left with just x by itself. And
3x, there's supposed to be a 1 there as the exponent, so 1 times 3 is 3. But then the exponent is x to the power of 0, which is just 1. So we're left with just 3. And the derivative of any constant is just 0. So that's our answer. Let's move on to the next one. Product rule to find a derivative of that right there. So we got term 1, term 2. So let's say we got our two terms, and we call our terms whatever, B and C. We've got two terms being multiplied by each other, right? So the derivative to find this is what you would do is you take derivative of the first, usually d dx, and you multiply it by the second, just the second alone, no derivative. Then you take plus the first times the derivative of the second. So once again, so this is what you're going to memorize forever. Derivative of the first times the second plus the first times the derivative of the second. Derivative of the first times the second plus the first times the derivative of the second. So in this problem we see that we have two terms being multiplied by each other. So derivative of the first, so derivative, we'll go slow so we catch it. Derivative of the first, which is all this, times the second, so 4x6 plus 2x5 minus 7x squared plus 2x, and we'll under plus the first times the derivative of the second, times d by dx of the second, 4x6 plus 2x5 minus 7x squared plus 2x. So let's go ahead and do this. So derivative of the first term. So 5x cubed, you bring the 3 to the front, so you'll go and subtract 1 from the exponent, so you got 15x squared. Derivative of 20x is just 20, and the constant is 0. Then you multiply this by 4x6 plus 2x5 minus 7x squared, 2x. And then you add the next term, which is 15x cubed minus 20x plus 13. And you take the derivative of the second here, so 24, and then you subtract 1 from the exponent, plus 10x4 minus 14x plus 2. So that's our derivative here. It's f prime of x is equal to that. So the thing to realize here is that we have to take the derivative of the first times the second plus the first times the derivative of the second. That's it. If you can be hardcore and multiply all this out, but I'm not going to do that here. It's going to take forever. Let's move on to the next one. Let's make sure we have some space here. So the next one says to use the formula from problem 7. Ignore that. Just find the derivative of gx 3x minus 2 over x squared plus 7. The point here is to show you that we're going to use the quotient rule. The quotient rule is that if you have two things being divided by each other, like in our problem, let's call this f of x, whatever. Derivative of f of x is going to follow. Okay, so low. So this is the top function, top part of the function. This is the bottom numerator, denominator. So low, we'll call this low, and this high. Okay, low, d, so you multiply, high, right, minus high, multiplied by d, dx of low, all over the low squared. So low, d high, minus high, d low, all over the bottom square. Just remember that forever. Like I said in my exam video, I learned it like that, and I remember it for the last 10 years. So let's go apply that. So low is x squared plus 7 times d by dx. D high, 3x minus 2, minus high, d low, d by dx. X squared plus 7 all over the bottom squared. So x squared plus 7 squared. Now, if we go ahead and solve this, let's move over here, we get, so x squared plus 7, and derivative of 3x minus 2 with respect to x will be just 3, correct? Minus 3x minus 2, derivative of this will be just 2x, constant goes to 0, all over x squared plus 7 squared. I'm sure you can simplify this somehow, but for now we'll just leave it like this because we got the point about derivatives. So let's go on to question 7. Alright guys, so now we get to the actual meaning of what is the derivative. The derivative is just the slope of a line tangent to the function at a certain point. So you see what I mean here. The question here is asking, find a slope-intercept equation, and that is the equation mx plus b, of the tangent line to the graph of the function f of x is equal to 4x cubed minus 7x squared at the point corresponding to x equals 3. So what you would do to find this, this is the slope that we need to find. And then we need to find b as well. So let me just, what we're going to do is take the derivative of this function. So 12x squared minus 14x. And if we go ahead and plug in 3 here, our given point, we'd have 12 times 9 minus 14 times 3. We get 66. So this is the slope that would go here. That is what the taking a derivative does. So so we have the equation here is now 66x plus b. We need to find this b value here. And we know that we were given the point x in the beginning of the problem. So if I plug that x into our original function, you'll get 4 times 3 cubed minus 7 times 9. And this will give you 45. So our point is 3 comma 45. And now I got my slope-intercept formula. I can plug in and solve for b. So I know that 45 will equals to 66 times 3 plus b. So we will get that b is equal to negative 153. So our final equation, the answer they're asking for is 66x minus 153. That's how you find that. Alright guys, so next question says to find the points on the curve y equals 1/3 x cubed minus x where the tangent line is parallel to the line y equals 3x. So we're finding points where the tangent line is parallel to the line y equals 3x. For two lines to be parallel, their slopes, called slope m, have to be the same. So I can find the slope of the line tangent here by taking a derivative of y of x. So y prime is equal to x squared minus 1, right? So you bring down the 3 and subtract 1 from the 3. This is the slope of the tangent line. And if I plug in a point, I'll have this specific slope at that point. So this will give you the slope, and it has to equal 3, the same as to be parallel with the line y equals 3x. So you have to make these equal to each other, right? So if you solve for x squared, you get 4, and when you take the square root, you can either be positive or negative 2. So it's asking for the points. So if we plug these values, positive 2 and a negative 2, back into our original function, y equals 1/3 x cubed minus x, we would get the points 2 comma 2/3 and negative 2 comma negative 2/3. That's it. Pretty simple, guys. Yes. Question 9 says to given a function that right there, find all points on the graph of f where the tangent line is horizontal. That tangent line being horizontal means the slope, call it m, is equal to 0. So if we take the derivative of this equation, we get, so 3x cubed would become 9x squared minus 22x.
15x would become 15, and the constant goes to 0. So this slope here has to be horizontal, so it has to be 0. So if we set 9x squared minus 22x minus 15 to 0, and we get, factoring this out, you can use either the quadratic equation if you want, but we get 9x plus 5, x minus 3, equal to 0. So x equals 3, or x equals negative 5 over 9. So these are points on the graph. This is the x values of a point on a graph where the tangent line is horizontal. To get the actual points, complete points, we plug them into our f of x. Original 3x4 minus 3x cubed. Okay. Minus 11x squared minus 15x plus 63. So when you do f of 3, you get 0, and f of negative 5 by 9, you get some complicated number, 16,384 over 243. Alright, so let's move on to the final question. Alright guys, we've reached the last question. I know it looks pretty simple, but I want to make a point here. So the question is asking us to find f prime of x. So normally you'd think, okay, this is a FOIL, okay, FOIL method here, FOIL, because we don't know what to do here, we see that exponent, so we just FOIL that out, right? So if we FOIL that out, we get is equal to 4x squared minus 12x plus 9, and now we can do f prime of x, so 8x minus 12, right? That would be the derivative. But let me ask you this. What is the derivative to 2x minus 3 to the power of 1 million? What would you do in that case? You can't FOIL, you can't multiply that out over and over again. It will take you years. So, in this case, we're going to use something called chain rule. And that will be the next video where I will do 10 solved problems on the chain rule. So guys, I'll see you guys in the next video. Don't forget to subscribe so you never miss out on any of my videos, and support me as well. Leave a like and share the video with all your friends so that we can all become successful. I'll see you guys in the next video. P.S. You guys can mellow out to this song if you want. It's pretty chill.